query the earth with an exclamation point for some reason. Okay. Jonah, I'm cartography lead at Meta. I'm going to talk about a little bit about how we get our data, what we do with it, and some of the data products we offer. Majority of maps at Meta start with OpenStreetMap. So we take raw OpenStreetMap data and we turn it into this daylight map distribution, which is a very clean, validated copy of OSM that also includes little sidecars we call, like buildings for Microsoft, or it might have additional translations provided by another partner. This is just raw OSM data. It's just a lot better. It's clean. There's no geometric errors, things like that might be in the source data. And then last year at NACIS, we talked about this Earth Tables project we started. So Earth Tables is kind of built on top of Daylight. It is a very simplified version of OpenStreetMap. So we took about 4 years of building our vector tile base maps. We took all the logic we learned over 4 years of building map layers and basically reapplied that to OSM and created this kind of cartographically driven schema. What that kind of looks like is thematic layers that map makers would be familiar with for OSM, and then a lot of cartographic data improvements. Some cool things we do there is like we intersect the OSM land use with buildings so that you can style the buildings and the land use the same way if you want. We do a lot of like just kind of quality of life improvements, like calculating links and areas for polygons and lines. For place names, we kind of simplify all those down into like 3 major classes and then provide a few subclasses that make more sense than like hamlet and neighborhood with a U and things like that. So all that data goes into maps at Meta. If you've used a Meta product, there's probably any number of places you might see a map from, like doing a check-in. Say you're traveling from somewhere, you're just verifying your location when you log in from another device. Instagram has maps, WhatsApp has maps. There's maps to help you find where to buy your Quest 3 that just came out last week. I'm just kidding. But other things like Marketplace, there's a rental thing on there. There's like places to find blood donation. There was a vaccine finder during the pandemic. So all of our maps, this is just like one general purpose map, serves a variety of products. And it's all starts from OpenStreetMap to Daylight to Earth Tables to this map we make. Some of the things we've been working on recently, one is this cartographic labels data set. So, cartographers, we like really nice, curved labels for water instead of just like a point in the center of it and just like a straight label. So we have a pipeline that creates these curved labels from OSM. So we take about like the 5,000 largest water features and generate those every time we get an OSM update, which is like every 2 weeks. And then we publish this out with Daylight, so you can just drag and drop it into QGIS or download the file yourself, and you don't have to make these really nice curved water labels for yourself. And another one that is we just released yesterday is a 1 to 1 million scale vectorized land cover data set. And we took ESA imagery, we downloaded all the rasters, we did a bunch of processing. We have 3 different scales. The large scale one is, we can't figure out a good way to deliver that. So we just made the medium scale one open source. And that is available today. So just some examples of this is what the cartographic data set would look, the label data set would look like in QGIS, just a bunch of lines that you can label. You would hide the lines and just show the water features. And then the vectorized land cover data set, the source had like 12 classes, and we kind of simplified it down to, I think, 7 classes, and it's a pretty manageable shapefile, and it's vectorized data, so you don't have to download the rasters and do weird raster stuff. So I'll hand it over to Jennings. Yep.
All right, thanks, Jonah. Hopefully we've made the case that this is a fantastic data set, and now you want to know how to use it and how to query the Earth. Easiest one, as Jonah just said, the vectorized land cover data set is just available as a shapefile, download, drag and drop. We're all familiar with that. The rest of the daylight Earth tables are released as a series of Parquet files on Amazon S3. So they're available here in this bucket, daylight OpenStreetMap /Earth. The files themselves are not meant to be downloaded, right? It's a directory of a bunch of smaller partitions, but they're meant to be queried in place, and then you download only what you actually want and need. So we're trying to get out of this world of downloading big extracts of data and then filtering it down further to what we want, and trying to really put that processing power, keep that in the cloud. Probably the easiest one and the fastest one is accessing through the daylight through Earth, accessing the Earth tables through Amazon Athena. It does require an AWS account, but it's very easy to get started. And this is a query to set up the tables. You just copy and paste it from the website, and you can start querying them. And we'll show an example in a second. DuckDB is a pretty cool, relatively newish approach to this. So this is running locally, and you're querying data sitting in the cloud, and you're just writing SQL in the terminal, and yeah, it's pretty slick. And then I actually just added this slide because Apache Sedona also makes it super easy to access these Parquet files. And so, literally that line I pulled out there is just sedona.read format, and you're just pointing it to that data. So quick example. Here's a query. We'll search for all the parks. We're using the quad key as a spatial filter here. I'm looking in the theme land use, and we're going to extract just the name attribute. So this is all the OpenStreetMap data, but now we just want the name and the geometry here as a WKT. And we'll just drag and drop that right into QGIS. And it's coming, right, I just downloaded that as a CSV, so you could run that through any other kind of filter you'd want, make a shapefile or something more performant. But then, yeah, we have just the name attribute was what came through there. And so we can then just confirm that. We didn't have to do any like fancy parsing of the name or look for certain languages. This was like we pulled the local name tag that we had parsed out. And so we think that makes it pretty easy. One more example, buildings. We can do the same thing. In this case, we have classes as well as on all the buildings. So we have a class and a subclass, and deriving that from OSM tags as well. It takes a little bit longer, just like 10 seconds, but returns almost 500,000 buildings for this whole quad key. And just same thing, download, drag and drop. Don't recommend big CSVs like this. You could convert this to shapefile or something else, but it does work. So that's the Athena approach. And we have example queries on the website as well to get started. This is what DuckDB looks like. Very similar, right? We're just writing SQL and downloading. In this case, DuckDB can connect directly to GDAL, and the output of this query is just a GeoJSON file, which is pretty cool. In this case, we queried the place name theme for the urban class. And we can see here we get some nice metadata. It's really small, but we can see that that's a capital place, yeah. And with that, I'm going to turn it over to Jake.
All right, thanks. So one of the questions we always get is what's next, what's coming up for sort of the Earth table and for daylight? And there's sort of a short and a long answer to that, and they're both the same, which is this new foundation called the Overture Maps Foundation. that we are, Meta is a part of starting. It's a multi-company collaboration started by Meta, Microsoft, Amazon AWS, TomTom, and participation of many others run under the Linux Foundation. So in a similar sort of philosophy, there's map data built jointly by the member organizations. So a lot of the work we did with Daylight, that Jonah and Jennings were just talking about, was sort of mostly done by Meta. And now we're sort of doing this collectively with a number of other companies. And the data is all free and released in the open in similar formats and ways to access it, just like we've done before. There's similar processes here for quality assurance, making sure there's not things like bad words and vandalism and graffiti and all sorts of other things that might happen in OpenStreetMap if you're to just sort of query or pull data from the live OSM database. And sort of a lot of continued work on a structured data schema for better ergonomics, sort of working with the data, whenever you're processing it or analyzing it. There was sort of this alpha release we had in July. We separated this data. There's something called places, POIs. There's transportation, which has a lot of the roads in it, buildings and administrative layers. The places theme is this new data set that was released. This is actually 60 million POIs from internal Meta places data that really has never been released before. It's always been sort of proprietary. And the two teams from Meta and Microsoft got together with their POIs, conflated them together, and sort of released this common data set that is now free and open. The buildings data contains conflated building data sets from OpenStreetMap and this Microsoft ML building footprints. So it's a total of 700 million building footprints globally. We're going to continue that out more. But basically, wherever we have an OSM footprint, that's maintained with all of its rich attributes, and we sort of fill in the rest with Microsoft ML buildings. It's pretty great. And kind of similar to what we were just talking about, all the data is still on S3 or Azure, and queryable using all the tools that Jennings was just talking about. There's this cool map here, Brandon Liu, I don't know if he's actually here, created quickly from the Places data set. You can go check it out and sort of click around and see what's inside there. So coming soon, I mentioned we just had those 4 layers before. We're sort of filling in the rest of everything you would need, what we call the base map or the base theme. That gives you things like the water and the parks and the beaches and everything else you need to build a complete map. So that's coming soon. We're going to have more buildings, so a total of 1.2 billion worldwide building footprints, more complete administrative areas, usability improvements, and things like that. So yeah, Jonah and Jennings made this map on the right here and kind of actually whipped this up pretty quickly after our data release. So yeah, it's trying to making maps with OpenStreetMap data and other data sets much easier. And with that, we can take any questions. Yeah.
You mentioned 1.2 billion buildings. How many buildings are there?
In the world? I don't know the answer to that. There's at least 2 billion, because we know that from kind of looking at Google has a similar sort of ML satellite-derived data set, and combined we think that's at least the size of that. But
we don't know what complete looks like, but
yeah.
we have to imagine that if we're going from 700 to 1.2 to eventually trying to get the Google data in there as well to 2 billion, we've got to be getting closer to complete.
Yeah. I'm supposed to repeat the question. It was how many buildings do we think there are in the world? Yeah. Yep.
Any plans for elevation or aerial imagery at all?
The question was, is there any plans for elevation or aerial imagery? I don't think at this time. I don't know if you guys have any more insight. Not in the near term.
Any ideas on expanding to digital surface models using the LiDAR data from USGS?
Any thoughts on expanding to digital surface models using LiDAR from USGS? So we've done some work to derive building heights using the LiDAR USGS data. So we can, sort of wherever an OpenStreetMap building footprint does not have a height, they can sort of derive that. And our team actually at Meta has done a lot of work there. So yeah, those building heights are there. I don't know how many. Do you know how many get added heights?
10 million, I want to say.
Yeah.
And new Microsoft data also has predicted heights.
Yeah, that's right. Yeah.
Obviously, buildings move from time to time, so I'm curious how often do you plan to update things like that? And as you're updating something at this scale, is there any versioning or like storing of historical data for future historical data?
Yeah, good question. How often are we, releasing new data, how do we keep it up to date? So Daylight has historically been on a monthly cadence that sort of tries to keep up with sort of what the latest OpenStreetMap is. All the historical data sets are there. I think we're going to get to something like that with Overture, hopefully sooner rather than later. We're still sort of working out a lot of the dynamics of big companies working together. But I would expect at least that kind of cadence, if not something much faster, you know, sort of next year probably. Do we have time? Yeah. Sure.
In terms of building outlines, are you using OSM building outlines in conjunction with Amazon, derived ones, or are you just using derived?
Yeah, so the question was, how are we deriving the sort of combined building footprint data set? Yeah, so the way it works is we sort of start with OSM, and all those building footprints get in there sort of verbatim and untouched. And then what we do is wherever there's an ML footprint from Microsoft, and hopefully soon to be the Google data set, they get sort of layered in as long as they're not overlapping anything. So we sort of conflate them in that way. I think long-term, oh, and that's right. And there's also Esri community data sets also get conflated. And actually, after OSM, and then the ML ones are sort of at the end there of the prioritization. Yeah. Yep.
When you say more complete admin boundaries.
Oh, yeah. Yeah. What did I mean by that? Yeah, what did I mean by more complete admins? I sort of just like skimmed right over that. The first data set we had, I think, just had country and maybe the next level down regional administrative boundaries. So there's going to be more complete sort of admin stack there down to, you know, city and neighborhoods and whatever else available. Yeah, sorry. All right. Thank you.
Thank you so much.